Welcome to Innovators of Tomorrow. I'm your host, Wendy Boswell, here to bring you the sights, sounds, and inspirational work from developers in our innovator community from around the globe. Today, we talk to Intel Software Innovator Lilli Szafranski of Lumina Labs and take a look at her project Stoicheia, a three-dimensional 2200 LED art installation. Let's get this started. All right, so welcome to the show, Lilli. Can you tell us what this project is about in a nutshell?
Stoicheia Elements is a 2200 LED hanging dodecahedron globe. It's got 12 sides. Each side has a different image in the center, and each side has around 180 individually controlled LEDs, and the LEDs run a program and change colors, and on the exterior it appears to be stained glass, but with all the colors changing.
So that is really cool. It's a very ambitious project. What inspired you to create this?
Well, my business partner and collaborator, hardware engineer Jesse Banks, and I had previously worked together on some smaller LED projects, and we had been talking for a while about trying to do something bigger, like a big LED art installation. Fast forward a few months from there, I was at Burning Man, and I came across a coffee table with some LEDs in it, and that's when the inspiration really struck, where I wanted to do something that looked like stained glass, but where all the different stained glass panes would change color because they had LEDs behind them. And so I brought that idea back to Jesse, and he really pushed for something three-dimensional. And so we spent a lot of time talking about what shape we could do. It was really important to me that each panel had symmetry, like the sort of rosary stained glass windows that you find in old churches. And then we came up with the idea of doing a dodecahedron because all of the faces of the dodecahedron are regular polygons. There are 5 sides, they have the same edge length and angles, and so it really had the symmetry that I wanted, but it had the sort of complexity and oomph that Jesse wanted.
When people see Stoicheia at various events, what is the response?
Well, people love it. It's an interesting story about the images that we decided to use for the centers of each of the faces. After we decided on going with the dodecahedron as the shape, we wanted there to be different images on each face, but we wanted there to be some kind of central theme that united all of the faces. And we weren't really sure what to go with, like what are there 12 of is the question there. And so I asked on Facebook, and I got a lot of different answers. One of my friends ended up saying Olympians. And so I Googled that. Apparently, the 12 Olympians are the main gods of the Greek pantheon, the 12 gods that live on Mount Olympus. So Zeus, Hera, Aphrodite. And it's great because they all have such great icons associated with them, like, Apollo's got the lyre. And so it was definitely like the theme that we went with. And so that's what all of the different images symbolize, are the different Greek gods. Well, it turns out there's a book series that's wildly popular called Percy Jackson that's about the 12 Olympians. And so every time we have the installation at museums or anywhere where there are children, they love it. They immediately recognize that it's the 12 Olympians. They go around, they point to each side, they tell their parents exactly which symbol represents which Greek god. And so that was actually a super pleasant surprise that I didn't anticipate.
This is a pretty amazing project. Can you tell us more about the software and hardware technologies that you implemented to get this going?
Well, so I'm a software engineer, and so for me, writing the software that drives the LEDs, that's where the real art came in and where I could really have the most flexibility and creativity. And so for me, I really wanted to take the opportunity to make something unique. And so I wrote all of the software by hand. It runs this algorithm that there's about 12 distinct modes that the installation can run at any given point. At the beginning of each mode, it makes a bunch of random choices. One of the choices that it might make has to do with the colors that it's going to be. Sometimes it'll only be one color at a time. Sometimes it'll be 2 colors at a time. Sometimes it'll be the full rainbow. Some other random choices are around how quickly it might render the pattern, how quickly it changes from one color to the next. Are all the LEDs moving in sequence? Are they moving with random times? You get all these different random combinations, and it's never the same. It's always different. You can watch it for hours and hours and hours, and it just continues to change and evolve and look different than what it did 5 seconds ago.
That is really cool. I like the idea of it never being the same twice. So as this was a really unique, kind of a one-of-a-kind project, were there some unique technological difficulties that you had to figure out and overcome?
Probably the trickiest part was drawing the imagery in a way that worked around the LEDs. So we started with this grid of LEDs behind each panel, and from that grid that is the same for all 12 sides, we then had to draw the images sort of around the LEDs in a way that no one LED can light up two different panes. So all the lines of the artwork, the things that are sort of segmenting it, have to work around this pre-established grid of LEDs, which is actually really challenging. It's really hard to draw a picture in the first place that looks like an owl or a deer or what have you, but then also do it in a way that lets each segment of the stained glass light up fully, doesn't create weird shadows, you're not splitting an LED between two sides.
So Lilli, tell us a little bit about how this was built.
Well, so Jesse Banks has a maker space in Beaverton, and he bought a pretty big laser cutter. And so I did all of the CADs, and we set the CADs to the laser cutter, where him and a bunch of our friends came about twice a week for a few months and cut all of the different panels from mostly acrylic, and people helped solder the LEDs together. The physical design was Jesse's. He also designed, with the help of some people, the tripod from which it hangs, and we had our friend and collaborator Egan weld that together for us. And we probably had a group of about a dozen people who came regularly to help build it, which was really exciting to see everybody in the community get excited about building it.
That is really cool. So you've come so far with this project. Where do you see it going next? What are next steps?
Well, I'm hoping to take it to a bunch of places this summer, which I should start researching now. We took it to a lot of different festivals locally. We'll probably pursue bringing it to Burning Man at some point in the future. I'm not sure if this year will be that year. I'm gonna look at other things like tech conferences. South by Southwest has art installations that they bring in, so maybe I will apply for that.
Thanks, Lilli, for coming on the show today. We loved hearing about Stoicheia and all the creativity and innovation that has gone into this project.
Thank you so much for having me.
You can connect with Lilli and follow along with her project at the link provided. And if you're feeling inspired by Lilli's story, learn more about the Intel Software Innovator Program. That wraps up this installment of the show. Be sure to like this video and subscribe to the Intel Software YouTube channel to keep learning about the innovators of tomorrow. On behalf of an amazing video crew, thanks for tuning in, and we'll see you next time.